So yeah, today I will be talking about Elixir 1.13 exclusively. But if we have time for questions, I'm not sure. I'll be glad to answer questions about anything Elixir, right? So why Elixir 1.13? So we are on the Elixir 1.12. Next one's going to be Elixir 1.13, and it's coming out this November. So we were used to release every January and July, but we shifted to every May and November so we can align with the OTP releases that come in May. So it's going to come next month, all right? And we almost hit 1,100 contributors. So if you want to be the 1,100, you can visit the issues tracker, and you can probably make it in time. And here, like I usually like to add some statistics about HexPM. It started a long time ago when we had like 500 packages, and like thousands of downloads. But now, we are almost 14,000 packages, almost 7 billion downloads. So those numbers keep on growing, right? And Elixir 1.13 is it's a very different release for us, for the maintainers, because most of the time when there is a new Elixir version, it's usually a mixture between like new APIs for users, for you, the developers, right? For us, the developers, and improvements to the tooling, right? There is usually a mixture of both. And Elixir 1.13 is different because like the huge majority of it is focused on the tooling, okay? So and we are going to see what are those improvements. So what this means is that most of the stuff that I'm going to talk about in this talk, you're not going to use it directly. Most likely, somebody is going to use that to build a better tooling, or somebody is going to build a package that you're going to leverage for that package. So so it's really focused on the tooling and more the low-level aspects of the language, right? So this also means that this talk, I'm a couple of times I'm going to go a little bit low level, but I'll try to balance it out and try to get everybody back. Okay. So what are we going to talk about today? We're going to talk about semantic recompilation. We're going to talk about mixxref. We're going to talk about code fragments and code formatting. All right. So let's get started. Semantic recompilation. So every time before I have to talk about Elixir compiling code, there is a very brief introduction that we need to make, okay? And we're going to go back in time a little bit. We're going to go back to Elixir 1.10. And in Elixir 1.10, so imagine that you have this module A, right? And you're calling B inside the module body. You're importing B, and inside the function, you're also calling B, okay? If you're calling something inside the module body, but not inside the function, we say that those things, they are compile time dependencies, okay? And what this means is every time B changes, because A has a compile time dependency, because we are calling B in the module body, A has a compile time dependency on B. So every time the file that has B changes, it means that A has to recompile. And that's why sometimes you're working on your project and you change a file and Elixir is like, hey, I am recompiling 20 files, okay? So so this is caused by those compile time dependencies. Is when we call modules outside of a function, okay? And Elixir 1.11, which I think was about a year ago, did one very big improvement in here where we changed imports to be export dependencies, okay? And the reason why this was important is because sometimes we have like compile time dependencies that have other dependencies. So we have like this huge graph. And as I said, that's why, for example, if you look here, Hex, the package manager that we use, it's a open source application. So I got Hex on Elixir 1.10, and I got the user file. And user is a file that is usually used throughout of our application, right? It's very common for us to depend on user. So in Elixir 1.10, if I change that file, only that file, and compiled, okay, it would say, I have to compile 90 other files, okay? Exactly because we had this compile time dependency, and then this compile time dependency would have other dependencies, so, it spreads around, then we end up having to compile a bunch of stuff. And with this change in Elixir 1.11, without doing any change to hex, okay, we just upgraded Elixir version, doing the same command now compiles 16 files only, okay? So this is an improvement we did in Elixir 1.11, okay, that improved a lot compilation, and it's really related to how Elixir is tracking everything, all right? So throughout the years, it's not only Elixir 1.11, throughout the releases, we have always been improving compilation, we're always listening to feedback and improve what we can. But today, if you go to your Elixir applications today, there is still one big issue. Even after those improvements we talk about, there is one big issue. And the issue is full recompilations. There is a big amount of scenarios. There are many scenarios where changing a file causes your whole project to be recompiled. So every time you change a mix.xs file, so for example, you add a new dependency or you change a configuration, every time you change the mix lock, so you update a dependency, remove a dependency, every time you change the config.xs or any other file imported from our config.xs, we are going to recompile everything, okay? And if you have Erlang files in that project, every time you change one of them, right, it's going to recompile everything. So depending on your application and how you're doing things, you're going to be seeing full recompilations frequently, which is quite annoying. And the worst part is that all of this is M-time based. All of this depends on the time the file was changed on the operating system, okay? And the issue with this is that sometimes simply like switching branches, right? And rebasing, for example, is going to trigger those full recompilations, okay? So even nothing changed at the end, it's going to trigger the full recompilation because we think that the thing changed on disk. So what we did in Elixir 1.13 in the next release was to solve this, like, considerably, okay? To the point that now, I'm going to show the end game where we got to, and then I'm going to explain how we got there, okay? So now in Elixir 1.13, we are going to trigger for recompilation if you change our mix.xs file, but if and only if you configure the Elixir compiler. So if you change how the Elixir compiler runs. If you don't change how the Elixir compiler runs, you can change the mix.xs file in any way you want, okay? And it's not going to do a full compilation anymore. And we are going to do a full compilation as well if you change your config.exs, but if and only if you are configuring your own application, okay? If you're configuring any other application, it's no longer going to trigger for recompilation. So moving to Elixir 1.13 is going to reduce the amount of recompilations as you work, as you switch branches considerably, okay? So how does this work? The whole idea here is that we have semantic recompilations, okay? So, and what we mean by this is that no more M time. Instead of saying, hey, was this file, the modification time changed in disk? We are actually going to try and understand what is in those files and do the changes necessary based on those changes. So for example, a very simple change that kind of kickstarted all of this was a contribution by Marc-André, which is before your Elixir files in lib, the .ex files, we would check the M time. So if the M time changed, we would recompile them. But now we also check their content as well. So this is a very easy and kind of silly semantic check, but it can already improve a lot. So if you change the file, if the modification time changing disk, but the content is the same, we proceed to compile the contents, the digest of the contents. And if the contents are the same, we're like, okay, I don't have to recompile this, right? Similarly, for the config.xs file, right? If you configure a dependency, now instead of recompiling everything, only the files calling set dependency recompile. So for example, if you compile, if you change the configuration for Phoenix, for example, only the files that are calling something from Phoenix is going to recompile. And sure, in a Phoenix application, you're still going to have a lot of files that are calling Phoenix, but for example, everything in your context, in your domains are most likely not calling Phoenix, and that doesn't have to be recompiled. And if you have a small dependency, right, it's nothing is not going to recompile anything, or just one or two files, okay? And again, we are only going to trigger for recompilation if you configure our own app. It's a solvable problem. We are just not there yet, right? So maybe not even this is going to trigger for recompilation in the future, but right now it does. Similar with mix access. If we change the mix access, instead of recompile everything, we just change the files that are reading the project configuration, right? And we are only going to recompile everything if you change the compiler options. Same thing with the mix lock. If you add, remove, or update a dependency, only files called inside dependency at compilation time recompile. Okay, José, this is nice. I think this is going to be great, or I hope that you think so. Does it mean that you need to know all of this? No, you don't need to know any of this, right? You just upgrade to Elixir 1.13 when it comes out, and hopefully you will be a more productive developer, all right? And there is one disclaimer here, which is those changes, they are changing to how Mix operates your project. So there may be bugs, okay? So I would really appreciate for those who can to go out to the Elixir GitHub and try out the master version. You can also, the website also tells you how you can use Elixir from source and really try it out in your project and see if anything goes wrong. How would be something going wrong here? So as you're working, your project goes into a state where it doesn't compile, and then you have like to remove the underscore build directory, right? So if things go weird and like, oh, I have to remove build for things to work, then it means that you may have found a bug, okay? So I would really appreciate if people would try this and give feedback. Some people have already tried this. I tweeted about this some time ago. Some people have tried, and the feedback so far has been overwhelmingly positive in terms of workflows. So I would really, appreciate more people trying, give more feedback, because I think this is a very nice change. All right. Still on the topic of compilation, one of the things that we have improved on 1.13 is mixxref. And mixxref, it's a task like mixcompile, mixrun, mixpaycheck server. It's a task that comes with Elixir, and it tells you information about your files and how they depend on each other, right? So if you go back to the example, right, of the module tracking example where you have A, and A is calling things on B. If you invoke mixxref passing the graph option, it's going to say, hey, lib A depends on lib B at compilation time, right? And this is kind of easy, right? You can say, hey, I can look at this file here, and I can see that it depends on B, right? No problem. But what happens when, for example, you get your Phoenix router, right? And for some reason, the Phoenix router, it's not supposed to have compile time dependency on most things, but for some reason, it has a compile time dependency on something, and your router is like 400 lines of code. How do you figure out where that compile time dependency is coming from, right? So you have to kind of know, or maybe the compile time dependency is coming from a macro, right? So you need to know how the macro expands. So, and you would need to know those rules. What is a compile time dependency, export dependency? So that's not very easy, right? So in Elixir 1.13, we added mixxref trace. And what it does is that you give it a file, and it's going to tell exactly where all of our compile, export, and runtime dependencies are, right? It lists everything. So now if you want to say, hey, there's a compile time dependency that is triggering that is making my application recompile a bunch of stuff. Now you have this command, the trace command, that is going to allow you to filter things. And you can pass the label option and say, hey, give me only the compile time dependencies, okay? So again, I think this is going to be really helpful for developers working on large applications. And we also added, this was another contribution for Mark Andre, who did a bunch of great contributions related to a compilation in mixxref. We also added the fail above flag. And what the fail above flag does is that it's going to raise if we print anything. So for example, imagine that you refactor your application, so you no longer have cycles in your code, okay? You removed all the cycles in your code. You spent like a day of work fixing everything, removing the dependencies, And then you're like, okay, this is great. And then you don't do anything. And then 1 month later, you're like, hey, I have 10 new cycles in my code, right? So with the fail above flag, you can say, hey, I want to check if there are cycles, and I want it to fail if there are more than 0 cycles, right? If I have any cycles. So now you can put this in your CI, and you can have your CI failing for stuff like this. Okay, so again, a huge thank you to Marc-André. He was also in the Thinking Elixir podcast talking about those things. So I recommend checking out that episode too. All right, so let's get out of compilation and let's talk about code, okay? So let me check the feedback here just to see if you're still with me, if I should slow down. Okay, everything's good. All right, so code fragments. So in order to, this is a new feature, this is a new functionality that we are adding to Elixir. And I will explain at a high level, what is the rationale for it and what are the issues that we have today and how we are addressing them, okay? So imagine that you are in your editor, okay? And then you're like, okay, I want to define a module, right? So you define the module, and then you're like, okay, I want to define a function, so called add inside the math module, and then you type a plus, and you're like, okay, I typed a plus, but now I need autocompletion, okay? You say, I need autocompletion here, right now, right? And the issue with this code, and the issue that your editor has to solve, is that this code is incomplete code, okay? This is incomplete code. Like if you try to compile this code before you type what you want to type, while you're asking the suggestion, right? The compiler is going to say, hey, this is invalid, this is a syntax error. But your editor needs to deal with this anyway, right? Your editor needs to handle the fact that this is incomplete code and show you a suggestion and use as much contextual information, variable names, whatever you can have about this, right? Your editor needs to be able to figure this out, okay? So what we are, and throughout the years, we have this functionality, right? And so, for example, if you go to the VS Code, for example, or anything that is using the Elixir language server protocol, they implement those things. Those features are there, right? And Marlon Saraiva, who works with me at Dashbit, he started the Elixir Sense package that adds those features. But the thing is that in order to implement this, in a way that is efficient, in a way that it doesn't have to handle a lot of weird corner cases, we need to make this part of the language, all right? Because integrated with the Elixir tokenizer, the Elixir parser, the internal toolchain of the language, if we integrate those things, then it's much easier to tackle those problems, right? So Code.Fragment is a new module in Elixir to work with incomplete code. And one of the reasons why we're adding this to Elixir, as I said, Elixir is the best place, right? Because we already have all the toolchain to understand the code. It's the best place to add this. But it's also because at the beginning of this year, we announced a project called Livebook, which is a collaborative and interactive code notebook in Elixir, so you can document stuff, you can write code, you can execute the code. If you haven't tried out Livebook yet, I really recommend you to give it a try and have some fun with it. And what we want to add to Livebook is to add this editor-like experience, right? Where you say, hey, I type enum.m, and then if you ask for autocompletion, as you can see here, we want to list everything that is there. And this functionality that I'm showing here, it was implemented with Code.Fragment, right? So we're already starting to use this, right? And it's kind of funny because, well, I'll tell the funny anecdote. So let me show more examples. So here's an example of us using Code.Fragment to show autocompletion. Here's another example of using the Code.Fragment module to show some mouse over context, right? So if you mouse over a map, so if you mouse over a dot, over the M, over the A, or over the P, we want to show the documentation for that thing, right? You just need to mouse it over. So again, you are putting the cursor somewhere and that code may be incomplete, and we need to figure out where the cursor is, what we are trying to call, and bring the documentation for that, right? So those are the challenges being solved by Code.Fragment. And let me tell you the anecdote is that the initial version of Code.Fragment, it actually came from IX, because if we use the Elixir, the interactive shell in Elixir IX, we already had auto-completion, right? You can type the module name or the beginning of the module name and press tab. You can type the function name. All this auto-completion stuff was already there. So what we did is that we extract this out into the Code.Fragment module, and now we are reusing it. And because we extract this functionality, as we are improving Code.Fragment now based on needs of like Livebook, we are getting new functionality in IEX too. So now, for example, in Elixir 1.13, we have struct auto-completion in IEX. So if you type the percentage sign and you hit tab, it's going to list all the structs that are available. You can, we also get CGU auto-completion, right? So if you type tilde and then you hit tab, it's going to list all the CGUs available for you. And then after you put the CGU name, the CGU letter, you can hit tab again, and we are going to show exactly how you can start that CGU. So again, those are very small features, but as we add all those conveniences together, I think it really helps the developer experience, right? And the fun anecdote was that, so I implemented this for IX, right? And then Marlus from Dashbit, he implemented it in ElixirConf that is being used by editors. And now Jonathan, he was working on Livebook and he was implementing those things for Livebook. So we're going to implement this thing for the third time. And then we're like, okay, it's enough. It's we should probably put this somewhere. And we realized that using Elixir for this is going to be the most efficient and productive way of tackling this. All right, so again, Code.Fragment, the odds that you're going to call a function in the Code.Fragment module directly is extremely low, but I hope as those changes start going up to the tooling, you're going to be using them every day. All right, and the last thing I want to talk about, the last big feature is code formatting, okay? So if we were at the event, I would ask how many people are using the code formatter, but we are not. I cannot see a quick raise of hands, but I would be curious on that. So the code formatter was introduced in Elixir 1.6, and the reason for that is that we want to ensure a consistent code style in the community, okay? And the code formatter is minimal configuration by design, and the code formatter expects files and strings as inputs, okay? And when we launched the code formatter, okay, it was very integrated. Again, this idea that it has integrated with how the language parses and so on. So it was using a lot of internal APIs to Elixir, which makes sense. It's a project, it's a module inside Elixir, so it can use Elixir internal APIs. And with time, we wanted to address this. So in every new release since 1.6, we were making all this internal functionality that is used by the formatter, we're making it public slowly, okay, little by little. And in Elixir 1.13, we have reached a very big milestone, because as I listed here at the bottom, the code formatter can only format files and strings, okay? So you cannot give it an Elixir ST. You cannot say, hey, I got this file, I changed this file, and now I want it to format it for me. I changed like the ST of this file, and now I want it to format it for me. You couldn't do that. In Elixir 1.13, we have two new functions. We have a couple more, but the two main ones are coded to algebra and coded to algebra with comments, which again, the odds that are going to call this directly are very low. But what this means is that now the code formatter supports strings, files, and AST as inputs, okay? This was contribution from Lucas Sandroman, and what it allows us to do is exactly that. You can now say, hey, you can like automate changes to source code, because you can say, hey, I want to read that file, I want to parse it, I want to change it, and I want to format it back. And Lucas has started this project called Sorcerer that has many conveniences to automate that, right? So for example, if somebody wants to implement a mix that's add thing that automatically adds a dependency to your mix access. I don't have to change it manually. Now we have the tooling to start doing this stuff, okay? And still in the code formatter area, we have one very nice addition is that mix format now supports formatter plugins. And what those plugins can do is that they can format custom file extensions and they can format custom sigils. So for example, imagine that in your application, you create this M sigil for Markdown, okay? And you are using Markdown and .md and .markdown files. And imagine that you want to format your Markdown. And for the same reason, you want to format your Elixir code. Paul, in the Lightning Talks, he talked about the surface formatter as well, right? So imagine that you have all those files in your application that you want to format. And you don't want to say, hey, mix format for Elixir, and then you want to have another command for formatting Markdown files, another command for formatting HTML, right? So we don't want to do this. That's why we have formatter plugins now. And now we can say, hey, I have a mixed Markdown formatter. It implements the mixed task format behavior, and it's going to change the code that is inside. It's going to format code inside the M sigil. It's going to change the code with the MD and Markdown extensions. So you tell the features that the plugin provides, and now you write the format logic, and now you have this integrated mixed format experience. And using a plugin is very easy. You just say, hey, I want to use the mixed Markdown format plugin, and you now include the extensions that plugin can format in your list of inputs, and you're ready to go, right? And I'm really excited about this because, as Paul talked about the surface format, and as Chris McCord talked about the new Hicks templates, now we can have all those things integrated. So now we can run mixed format, and it's going to format your Elixir code, it's going to format your H sigils with Hicks templates, it's going to format your .hicks extensions. So this is going to enable a bunch of really, again, tooling, right? Tooling, right? I'm almost channeling my inner Steve Ballmer here and talk about tooling. But yeah, it's all about better tooling, proven tooling, and so on. And of course, we have general improvements. And so just to the very tiny improvements that we added here and there. So for example, we now, after almost 10 years, we have a power operator, right? So for power mathematical operation as part of the language and part of kernel. We added things, convenience things for validating keywords, saying like, hey, the keyword has those keys, and those keys, they must be there, they're required. You can now, conveniences for mapping and filtering a map and getting a map back. And also new additions like task completed and task ignore. Like sometimes, for example, there is an API that is expecting a task, but you already have the task result. So you can just say task completed to create a task that is already completed, so you can give it to that without starting something separate to process it. And we also have now task ignore. And what task ignore does is that, for example, imagine that you want to start a task to do something, and you want to wait 5 seconds. And after those 5 seconds, you're like, you know what? That task can finish. I'm no longer interested in the result. It can finish on its own, right? You can't do that today, right? In Elixir, what you can do today is that you can wait for 5 seconds, and then you can say, hey, I'm going to crash, or you can say, hey, I want to shut down the task. But you can say, you know what? Leave it running, but don't send me the result anymore. I don't care. I'm no longer interested. And now you can do that with task ignore precisely. Okay. So that was it for what is coming in Elixir 1.13. And I want to take the next 5 minutes to talk about what is next for the Elixir language. And if you see me giving a talk in the last 2 years, this is going to be the exactly same stuff, right? Nothing has changed, right? So what is next for Elixir? So new versions will continue to come every 6 months, right? So Elixir is stable, no plans for a major release. So those 6 months, again, they are all improvements like we just seen in this presentation. We are continuing to improve what we can, things that people bring up and so on. So no plans for a major release. There are no plans for an Elixir 2.0 at the moment, right? And we do have a general direction, right? So one of the general directions is tooling that I've talked a lot about today. Um, and the other direction is compiler assertions. And I've talked this a couple times. I'm going to give a quick refresh. I like to say that Elixir code is very assertive, right? We usually have pattern matching, we have guards. So a lot of the times we know what are the types that we are working with. And I think the compiler can use this information to find bugs earlier for us during compilation. And we already added improvements to Elixir in this direction in the last releases, and we'll continue to do so, right? So that's a general direction. We don't have like a end goal in mind, like, hey, we want to get this. It's just something that we are chipping away and exploring, as things pop up and as we have ideas and so on. Generally speaking, we have a mostly empty backlog. So if you go to the issues tracker today, we are going to see that a lot of the issues in there is mostly about catching up with Erlang OTP, right? So one of the things that we also want to do is that every time there's a new Erlang OTP release, we want to make sure that we are leveraging the greatest and the best that there is in it, right? And this brings me to the next point, which is the reason why we can afford, right, to be stable, right, to have a mostly empty backlog is thanks to the ecosystem, right? We build on top of Erlang OTP, and really the bulk of the work, right, the Herculean effort is happening on Erlang OTP, right? So all the performance improvements that we see, making the VM more efficient, the new features related to distribution, to the process model, it's all happening there. Okay, and as an example, right, the just-in-time compiler that came with Erlang OTP 24 is amazing. For me, everything is easily 33% faster, but often more. So it's just fantastic, right? And the other reason where Elixir can be at this space where it is right now is because of you, because of the community, right? We enable the community to build on top of Elixir. So Elixir is an extensible language. Everybody can get Elixir and bring it to new domains, to new areas. And again, one example that still blows my mind, even if I was involved with it, is the NX, the Numerical Elixir project, where now we have a subset of Elixir that runs on the GPU, right? And this is amazing. The fact that we could do this without doing a single change to the language, I think is a good testament for the language being an extensible language that is going to allow us to bring us to new areas, new places, and continue improving those areas, right? And to continue this trend of thanking the ecosystem, I would like also to plug in the Erlang Ecosystem Foundation. The Erlang Ecosystem Foundation has been doing great work in improving both areas that we talked about, both Erlang OTP and the community. So just some examples. We were just talking about the JIT, right? And the Erlang Ecosystem Foundation sponsored some of the work, so the JIT can work on ARM64 machines like Apple M1. Okay, so this was work sponsored by the Ecosystem Foundation. The Ecosystem Foundation also sponsored Thomas to work on float to string conversion, which is something that you would think it's straightforward, convert a float to a string, but it actually isn't. It has like literally decades of research into it if you want to get a float and get a string, the smallest possible string representation of that float. And over the last years, we have advancement in the research, and Thomas brought this to their Erlang virtual machine. And this leverage, and most apps, they're going to leverage this, right? Because, well, if you're sending things to the database, you need to convert a float to a string, so you can send that to the database. If you're using JSON, if you're printing a float on an HTML page, it's there all the time, right? And this is work now that is in Erlang OTP, sponsored by the Ecosystem Foundation too. And for example, there are a lot of working groups in there. The machine learning working group, everybody's there talking about NX and everything that is happening in this machine learning area. So I recommend you to join the Ecosystem Foundation if you have not yet. You can be You can be a non-paying member, but you can also join as a voting member and participate actively in the future of the foundation. And I would also advise companies, right, to join as sponsors. A company cannot be part of the foundation as an entity that votes, but you empower the foundation to continue doing work and improving the ecosystem through sponsorships. All right, so that's it. So thanks everybody for your time and your attention, and see you around.